Testing. All right. Better? Worse? All right. Sounds like we're good. You good? All right. Good afternoon, everybody. Going to go ahead and get started. Today we're going to give you a sneak peek of a project we built called CBFT. This is a full, all right, still having some audio problems. It's a full text search engine for Couchbase Server. I'm joined today by Steve Yen. Hey, everybody. Steve Yen is a co-founder here at Couchbase. And I'm Marty Schoch. I'm a lead contributor on a project called bleve. It's a full text search engine that we've built in Go. And we've built CBFT on top of that. So what's our agenda today? First, we're going to talk about why we built CBFT in the first place. I'm sure a lot of you are wondering that. Then we're going to do a quick review of full text search and how it works. There's a couple of misconceptions people have about how full text works, and by getting a deeper understanding of that, it's going to help us understand why we designed it the way we did. At that point, I'm going to hand it over to Steve, and he's going to go through the design and do a short demo. I'll wrap up the demo with a more advanced example, and then we'll look at the future. So why do we build CBFT? As many of you know, we have Couchbase connectors that work with all the major search engines that are out there. I myself worked on the Elasticsearch adapter. I built applications with Elasticsearch. It's very successful. I recommend it to you if you're needing full text today. We also have adapters for Apache Solr and LucidWorks. But they all come with a bit of a price. If you want to run them, even if you just need the smallest feature in them, you need to run a separate cluster to support them. That comes with both an administrative cost, management cost, your time, and more things to worry about going wrong. So we asked ourselves, maybe we could take the same approach we take with everything in Couchbase, offer something that's simple, easily integrated. And do we need to deliver all the features that Lucene has? Lucene's been around for 20 years. It's got a long list of features that's been built. But we think a lot of our users maybe can get started with just the first 80%. So we're taking this 80-20 approach where we can hopefully get something that's usable out of the box really quickly. So at this point, we're going to take a little bit of a detour. We're going to do a quick review of what full text is and how it works underneath the hood. So this is probably the first thing everybody thinks of when you talk about search. Google gives you a box. You can sort of just type in some text. Yeah, there's some advanced syntax, but you don't need to know that. You can just type in what you want, and it's up to Google to figure out what you mean and give you the best results it can. So that's one thing we're going to look for. Sometimes, though, you do need an advanced search, where you're going to have separate fields broken out. Maybe you want to search for phrases, exclude certain terms. Maybe you want to also add like numeric and date ranges to sort of control some of the parameters in your query. So you also want that ability to have a detailed, more next-level search as well. Then when we turn to look at the search results themselves, there's a couple things to call out. One, I intentionally misspelled it for the search to trigger this, but it's very common that you see search suggestions, spelling suggestions. So if you misspell something, the search engine is going to tell you, I didn't find a lot for that, but there's this other term that's close, and it has a lot more results. That's also a navigation aid, right? You're going to be able to click on that and go ahead and repeat the search with the correct spelling. Looking at the results themselves, you have these result text snippets. So that's a little bit of text from the original document that you're presenting to the user along with the results. That helps give them context as to why this particular result is in the result set in the first place. And then you really want to take it a step further. Here we see the term Couchbase has actually been made in bold. And that shows the user, again, that's the term they search for. That, again, calls it out to them even more clearly. That's why that particular result is in the result set. And one thing that I would say is really popular, particularly with Elasticsearch, was the introduction of faceted search. You see this on almost every retail site that you go to these days. Here I've done a quick search for Couchbase NoSQL, and you see some books on the right-hand side in the search results. That's really not what we're going to focus on, though. If you look in the left-hand corner, you see there's categories, and then there's numerical counts next to them. And that gives the user two things. One, it gives you an overview of the whole result set because you can see how the results break down into those different categories. But again, it also serves as a navigational tool because you can click on those and then drill down deeper. So it's very common to start out your search for some purchase by doing a broad search. Maybe I'm searching for televisions. And then you're going to be able to drill down by, OK, I want something bigger than 20 inches but less than 32, or less than $200 but more than $100. And these are all categories that you can drill down into, and all that's powered by faceted search. So those are some of the things we're going to look for in a full-text solution. Let's look a little bit about how this is actually working under the hood. So here we're focusing on how we would integrate this with Couchbase. So here I have a JSON document. It has the key AK1980. The document has two fields. First is the name, Alan K, and then we have a description. Now you can imagine this being a longer piece of biographical text. We're just going to focus on three terms here that I've called out: the wisest engineer. And now we're going to see how that would actually end up being indexed. So when we look at full text search, we talk about a process called text analysis. And this is how we're going to transform the terms of the text that are in the source document into the actual items or terms that are put into the full text index. And we can think of that as a pipeline of transformations. First, you're going to have a single tokenizer, and then that's going to be followed by 0 more token filters. We're going to look at those in more detail. So here I show the tokenizer process. So again, the input that we started with was some larger text with the phrase, the wisest engineer. And the output of the tokenization process is going to be the discrete terms, the, wisest, and engineer. Now, it looks just like simple white space. As human beings that speak English, we see those are just words that we're separating. But for computers, it can be a little bit more complicated, particularly when you want to start supporting additional languages. Now, the Unicode standard has an Annex 29, which goes into some details about how you can do this in a more general way. But it's important to realize that those are still just defaults and recommendations. There's still places where you have to override and customize that. Another good example would be that email addresses and URLs are texts that occur inside of all kinds of languages, but don't follow the traditional rules for punctuation and spacing. So the main takeaway here is that tokenization can be more complicated, but it's simplest to think about it right now is just splitting it on the white space. After the tokenization occurs, we have these tokens. We're going to do the token filtering process. So here I show two token filters here. The first is one we call stop word removal. Stop words, when you're dealing with full text search, are words that occur very commonly in language. So they tend to just not add a lot of value to the meaning of the text. So in this case, the word the, other words like and, but, or, to, these are all words that all occur so frequently they don't help. So that's going to be removed as a part of that token filter. But you notice the other two tokens pass through as is. The next one we have is a token filter that's called stemming. Now, generally, you're going to choose a stemmer based on the language. So you would have different rules for different languages to perform the stemming process. And this is going to generally transform words to more of a root form. And that, again, allows you to increase the number of terms that ultimately are going to match the original document. So again, even in the case of English, you might find there's 5 or 6 different algorithms that perform stemming that have different characteristics. Again, this one here is a very simple one that's just trimming us down to the root word. So at the end result of this, we have 2 tokens left, wise and engineer. And those are the terms that are going to be put into the index. And I put a little illustration here of a sort of a logical representation of what this would look like. So on the left-hand side, that column there, we see those are the keys in the index. And on the right-hand side, you have the list of document IDs that ultimately are corresponding to that. So engineer, we see the key AK1980, and wise, likewise, has that same key. Again, this is just a logical representation. That's not the actual structure we're using, but just to help understand how it works, that's what we see. Now, what happens when someone comes along and wants to perform a search? So here I've shown the search box here where someone's come along and they've typed in the search engineers. What we're going to do is we're going to apply the exact same analysis on those search terms that we performed on the documents when we indexed them. So that means the same token filters, the stop word removal and the stemmers are going to be applied to the search terms. So engineers is now going to get stemmed down to engineer. The reason we do that is now our search execution is just performing an exact match of the terms that they searched for after analysis and the terms in the index. And I just want to call this out because a lot of people feel like there's a lot of fuzzy matching going on. And while that can be a part of full text search, I would say the core of full text search is really this exact matching of terms. It's important to understand that. Now, that's how we determine which documents ended up in the result set. But if you have a Couchbase bucket with millions of documents and you search for something broad like engineers, you might have 10,000 documents or more that match. So how do we determine which of the 10 that you're probably going to see at the top of your search result list? That's where we get the document scoring. CBFT that we're looking at today implements something called TF-IDF scoring. It's not the only scoring mechanism, but it's a fairly popular one out there. It sounds a little confusing, but it's actually really simple to explain. So the TF stands for term frequency, and that relates to how frequently the term occurs in the document. So if the one document we're looking at, say, maybe it used the term engineer 100 times, that's going to score higher than a similar document which only used the term engineer 10 times. So again, more often a term occurs, the higher the score. The second component is what we call the inverse document frequency. So this relates to how many documents out of the whole document population use that term. So again, if I had a Couchbase bucket with 1 million documents, if 900,000 of them all use the term engineer, what that's telling you is it's not a very, it doesn't differentiate that document from other documents because they all tend to use that word. So you have terms, if you have a term that's more unique, that's going to ultimately serve to score it higher. So again, the more documents that use that term, the lower the score is going to be. Now, why do I go into all this detail? Because at the end of the day, you want high-quality search results. So any solution that we build has to be able to deliver you high-quality results. And getting high-quality results in full text is really about performing the right analysis on your documents. That means a lot of tailoring things to languages, your domain. There's a lot of things that go into it. It's very rarely as simple as just check the box and turn on full text. And I also want to call on this slide here because as you adjust your analysis, right, it's generally an iterative process. You start with something, the results are okay, but not great. You tweak it a little bit. But it's important to keep in mind, when you're making it better for one search, you may actually be making the results worse for another search, right? So I don't have a magic recipe to give you. I'm just saying you need to sort of keep that in mind, that you want to have sort of a whole suite of things that you're testing as you go to improve things. So with that background on full text, I'm going to hand things over to Steve Yen, and he's going to talk a little bit about the design of CBFT.
Yep, cool. All right, thanks Marty. So there's good news when we're almost done with halfway done, I guess, with the presentation. So we're that much closer to the party and to the beer. The other thing is all the stuff that Marty just talked about in terms of scoring and TD-IDF and all that stuff, it's actually available as this open source library in Golang, which is really cool if you're a Golang geek like me. So there are actually multiple applications that are using this thing already, integrating in this Golang library called, Marty calls it bleve. I think the rest of the world calls it bleve, but that's what it is, Linux. One of the applications that is actually using it is CBFT. So what we're doing is we're using CBFT as a library underneath the hood in order to handle all our full text indexing capabilities. But on the other side of it, CBFT is actually integrating in data that comes from Couchbase. So let's talk about how that actually works. One of the things that CBFT adds to the picture is it actually will partition the indexes and send them across to multiple bleve full text indexes. The way that works is you're going to get data from your Couchbase server. Some of you might know that Couchbase, when you have a bucket, for example, your beer sample bucket or your CRM bucket or whatever bucket, those buckets are actually partitioned into multiple vbuckets or multiple shards. For example, there are going to be 1,024 vbuckets. That's what we call it in engineering. So here you're seeing 0 to 1,023 vbuckets. And then when you create a full text index in CBFT, it's actually going to partition that into multiple partitions. I show 3 partitions here, A, B, and C. And there's a pretty simple algorithm, a modulus-based algorithm, to assign those vbuckets to those index partitions. So for example, index partition A gets vbuckets 0 for 399. Index partition B gets 400 for 799, and so on and so on. Now, at this point, everything is sort of like this logical meta kind of maneuver at this point. What happens next is you're going to have one or more CBFT nodes, actual nodes, and CBFT is going to assign those index partitions to your nodes. So what happens is as you keep on adding more and more CBFT nodes to your CBFT cluster, the CBFT can automatically reassign your index partitions across to those new nodes that are added to your cluster. And one of the features that it also has is the ability to configure replicas of your index partitions, so that as you add, replicas will basically be assigned to the multiple CBFT nodes. And that's important, of course, if something happens, the chaos shark shows up and chomps on one of your nodes, takes it down. That means your queries and index updates continue to happen. And the way it happens, of course, is that we're actually using DCP streams. So CBFT is actually making DCP connections to Couchbase server nodes in order to get the various vbucket data streams to the relevant nodes. And that's important. DCP is a good maneuver in terms of if a node goes down and restarts. These nodes, because of DCP, they don't actually have to restart from 0 in terms of their full text indexing. On the query side of things, your application when it wants to make a query, can make a REST call to any CBFT node. It doesn't matter which one. And underneath the hood, CBFT is going to route and gather that request to all the other nodes, all the other index partitions, gather the results, merge the scores, provide you back one result. Today, this is a REST call, so you could do it from command line and curl. In the future, this is going to be actually integrated into our SDKs, and we'll have a higher performance binary protocol that will be better. So that's like the high-level hand wave. Now let's jump into the demo and actually show a little bit of what it looks like. So there we go. Over here. I actually have a 3-node cluster of CBFT running. Got like 3 tabs. Oops, it's not on the screen. Oh, interesting. Well, it works on my screen. Any help here?
Is it a mirroring issue? Are you not mirroring?
Possibly. Okay, I'm going to unplug this and replug it back in. Any help? Do I drag a window around?
You have to duplicate. There you go.
Oh, okay.
Yeah.
Here we go. All right, so I got 3 nodes of CBFT running. And one of the things it tells you, although you can't see it because the font's so cranked up, is a little URL that you need to visit in order to see a web UI console, which I'm going to drag over here too. Oops, that didn't quite work quite well. Let's see, we're using a Bootstrap-based CSS. Yeah. All right, if I make the font smaller, now it works. So you see this nice welcome to CBFT screen. Along the top here, there are various buttons in order to get more screens. There are links to help. Logs, manage, and monitor are all about like operational concerns. So there's lots of interesting statistics and data that you can get as you run this. I can see that I have a 3-node cluster running here. If I go back to the indexes screen, one of the buttons you can press now is the new index button. It's cranked on the font. Let's go ahead and create an index. So in my Couchbase server, I already have a beer sample bucket already preloaded, so we're going to call this the beer sample index. Choose an index type. CBFT supports multiple different index types, so we're going to choose full text here. And you could choose different settings for your index mapping. We'll just leave it for default for now. On the source type, you can get actually data from different data sources. We'll just choose Couchbase for now. And type in our bucket name, beer sample, and hit this create index button down at the bottom. And there we go. There's a monitoring tab where you can actually see interesting statistics about how it's proceeding on its indexing. There's lots of juicy information here. A lot of these things will be, in the future, integrated up into the Couchbase server and a server in the graphical UI. There's a little bit of a management screen here that actually shows me how much index partitions were actually allocated across the 3-node cluster. I have like 4 index partitions, and these green boxes denote like which CBFT node is actually assigned to service that index partition. Let's go ahead and go back to the query tab. So I could type in now at this point a query, and nothing pops to mind except for beer. So there you go. A nice result. You can see all the different JSON fields of the beer documents have been indexed. You see some syntax highlighting here. If I click on this show scoring checkbox, you can see information on how bleve actually did its TD-IDF scoring. And if I come back here to the main indexes screen, I can see my beer sample index has been listed here. I can edit, I can clone it, I can delete it. And at this point, it's probably good to hand it back to you, Marty.
Okay. Thanks, Steve. So what Steve showed you, I think a real takeaway there is just how simple it is. You can really look ahead at a future version of Couchbase, and getting started with this will be as simple as checking a box and bringing up a full text index. But we all know if you've built anything with Elasticsearch or Lucene, it's never that simple, right? There's always some advanced mappings that you're going to need to customize. So what I want to do, we have a lot to show, but we actually don't have time to show it all. So I'm going to show one simple example, how we can customize the analysis pipeline that I talked about earlier and change the output of the results that we get. So let's go ahead and we're going to create a new index. This is going to be, just to give it a different name, we're going to choose the same index type, which is bleve. This time I'm going to select custom. And when I did that, you notice the UI changed, a whole new section, 2 new sections showed up here. The top refers to the document structure and how we want to index, the indexing behavior for different parts of that document. And then the bottom section is where we can make definitions to describe new components in the analysis pipeline. What I'm going to do is just as a simple example, we're going to create a new token filter. So right now we notice there's nothing in the list. It's empty. We haven't defined anything yet. So I'm going to hit new token filter. And here we have a UI where we can build custom components. And we're really customizing various things that are available to us. So there's a variety of different kinds of token filters available. I don't have time to go into all of them, but again, you'll see things for stemming. You'll see stop words as options there. What I'm going to do is choose the one called length. And this one has 2 parameters. Again, that UI is dynamic. So if I had chosen a different token filter type, the UI would have given me different options below. But the length filter has a minimum and a maximum. So what I'm going to do is I'm going to change it to set a minimum of 5, and I'm going to get rid of the maximum. So what this is going to do is as tokens are being processed, anything that has 5 or fewer characters is going to get thrown away. And we need to give that component a name, so I'm going to call this, I don't know, not too short, and we'll hit save. So we see that in the list of components there. Now, the token filter by itself is not being used by anything. It's just a token filter. We would then want to use that in what's called an analyzer, and the analyzer groups together all the components of that pipeline. So we're going to create a new analyzer. Again, there's character filters, which we didn't talk about today. There's the tokenizer, which is set to Unicode. That's going to implement the standard Annex 29 rules out of Unicode that we used earlier. And then we have token filters, which are not quite fitting on the screen. Let me see if I can make the font a little smaller so we can see it. Here we have the token filters. So what we're going to do is if we scroll through that list, we're going to see the not too short one that I just defined. I'm going to press the add button, and we see that in the list here. Now, because this is a pipeline, the order matters, right? So if we were to add another token filter, let's say, I don't know, Elision GA, and add that, there's a nice drag and drop UI where we can rearrange them and customize the behavior that we're looking for. In this case, we don't want that one, so we're just going to remove it. And that's all we need. This pipeline could be simple, right? It just has the Unicode tokenizer and the not too short token filter. Now we just have to give it a name. I'll call it NTS for short. Now, after all that work, we still only define an analyzer. We still need to tell it to use that analyzer for a section of the document. So now what we're going to do is we're going to scroll up a little bit. In the document structure section, we know that the beer sample documents, which are JSON, have a field called description. So I'm going to go ahead and add that. If I select that, I can then, on the right-hand side, change the behavior for how that particular section of the document's indexed. So I'm going to tell that that's text. The analyzer is right now set to inherit, right? So it by default, it would inherit the behavior from the parent configuration, but we're going to now override that and use the analyzer I just defined. There's some additional options we won't look at today. That should be all we need to do. I still need to tell it where to get the data, which is the Couchbase bucket, beer sample, and we should be good to go. So all of that extra UI, what that was really doing is behind the scenes, there's a very rich JSON structure which describes all the things we built. So the UI is very new. So that's something that's going to be improved over time. But the idea is it's going to allow you to make all those complex tweaks without having to dive into the low-level JSON, which, as you can see, gets pretty messy pretty quickly. But let's see if it works. Let's go over to the query. Now, last time, Steve ran a search for beer, and that had a lot of matches. Now, we only changed the behavior to the description field, so I'm going to limit this search to the description field. But if we run this now, we get no results. And the reason is all the terms beer have been thrown away because they had less than 5 characters. And just to sort of make sure that it's still working at all, let's try a longer term. Let's just do flavorful as another search. And we see that did still work. So everything in the description field was being indexed, but now we just threw away the ones with those shorter terms. So it's a bit of a contrived example, but it shows how you do have all the additional knobs and hooks that you're going to need to sort of tailor the mapping for your particular data set. So with that, I'm going to jump back into the presentation. Maybe. So what's the current status? Where are we going from here? Well, we're happy to announce that as of today, CBFT is now in a developer preview. And this is where we need your help. We have a lot of people out there that are already using Elasticsearch, and you guys are the best test case, right? We want you to give this a try, go to the forums, and be able to give us some feedback on what we got right, what we got wrong. The URL is up here. It'll be on a slide later as well. I can see a lot of cameras in action, so I'll leave that slide up. Again, that URL is going to give you the downloads, the documentation, and again, links over to the forums where we want to engage with you and make this thing better. So the current status, as you already saw, we're using the bleve full text engine underneath to do the indexing. We do have support for advanced mappings. That's something where the UI is going to improve over time. We didn't see a demo of it today, but we do support faceted search out of the box. It's, again, a very popular feature. The indexing is incremental. This is built on top of the DCP protocol that you've probably heard more about today at Couchbase. As Steve demoed, we have indexing, partitioning, replication, right? So we already have support for some of the lower level features we're going to need to make it this highly available, like you would expect with the rest of Couchbase. And again, there's another feature we didn't demo today called index aliases. So this allows you to run a search across multiple buckets. So if you're already partitioning your data and storing data in different buckets, a lot of times a need kind of crops up late in your requirements where you'd really like to be able to search across all of them, and this index alias feature allows you to do that. Looking to the future, obviously, complete integration with Couchbase Server is the goal, and we are really excited to kind of get to that point because we've seen how we're actually following the same pattern we used last year with Nickel. Nickel was in a developer preview as a standalone, and so we have that path kind of paved for us in terms of how we're going to go about integrating this with Couchbase Server, and we're really excited for that. Nickel integration is also something that everybody asks about. It's definitely on our radar. I'm not going to, I have them on one bullet there, but I don't want to make you think they're necessarily going to come at the same time. Those two things may come in different iterations, but Nickel integration is very important to us as well. Now, getting into Couchbase Server implies a lot of these other things. API stability, right? That's something that's going to be part of this, production quality, performance tuning. We didn't talk a lot about it, but I believe Chung mentioned in the ForestDB talk earlier that we also support using ForestDB as one of the storage mechanisms. And so that's, again, something that's going to be coming as a fully featured part of this as we roll it out in Couchbase. Couchbase has, really trying to step up our game with respect to security and SSL. So again, that's something that's going to come along as we integrate more fully with Couchbase Server. Documentation examples, and again, Steve mentioned it, SDK support. Right now, everything you're doing is REST-based, but the end game here is that you're going to be able to use the SDK the same way you do your KV access, the same way you run your Nickel queries. You're going to be able to use that same SDK to perform your full-text queries as well. So we're really excited about the future. And like I said, here's the URL. We'd love for you to go download it, take it for a spin, let us know what we got right, what we got wrong, and like I said, communicate with us about it. So with that, thank you. And please do fill out the survey for this talk as well. Thank you. I think we have time for questions, I believe, so. Any questions? How does it differ from Solar? Well, I would say first and foremost, it's a single infrastructure. So I would say feature-wise, it's going to be very similar to Solar. And from an application developer's perspective, you would maybe even hope that it would be identical to Solar in terms of the features you're going to get. But the main, I would say, driving force is the simplicity of not having to run and operate a separate cluster. Yep. Autocomplete, that's a great question. It's something that bleve has partial support for right now, and we do want to support it. I mean, come on, we have to, right? I mean, we pretty much have to have autocomplete, some sort of solution for that. So it's going to be there. I would say it's not there yet. Maybe in a future developer preview, we'll get that added. I'm sorry, could you speak up? I'm having trouble hearing you. You're right. So the question was, could we not have just integrated with Lucene instead? And what is this search that we're using, solution that we're using? So you're right. I would say Lucene is great. I've built applications on top of it. I would say for us, the main reason is If Java is already a part of your stack, then choosing Lucene is kind of a no-brainer. But if Java is not already a part of your solution, introducing it can sometimes be kind of a high bar to meet. It's, again, running the JVM is great, but you need a certain level of expertise to do that. So that was one of the major reasons, was if we were to go on a Lucene-based solution, we would be introducing some sort of Java-based component into the architecture. That wasn't the only reason why we didn't choose that, but I would say that was one of the largest ones. The library we are using is called bleve, and that's something we've built internally. I'm the primary contributor for that, and that's a project written in Go to do full-text indexing. It's very analogous to Lucene. It's not a port of Lucene, but I would say feature-wise, it's very similar in terms of its attempted scope and behavior. We've been using Go for quite a while at Couchbase. I actually have a talk on that tomorrow. So if you're interested in some of the history and lessons of using Go, I would recommend you attend that talk. In short, I can say it started as in our labs team, where we had a lot of freedom to choose whatever tools and solutions we wanted. It became very popular amongst developers. And that's sort of a theme I've seen, that developers tend to really like using Go. But to be fair, I would say that's not the full story. When you choose a language in a company like Couchbase, there's another side of it, right? We're running code on customers' machines, and so that implies a certain level of support and things that we still have open issues on. So it's an ongoing story. I'm going to tell you, like I said, more about that story tomorrow if you're interested. But that's where we are with Go. Yep, behind you. The take on MarkLogic's full-text search. I'm sort of vaguely familiar. I've read a paper on like their approach, but I've never used it myself. So I can't give you a good answer on that. But if you want to talk offline afterwards, we could chat more about that. Yep. Dynamic mappings? So you mean in terms of changing the behavior? Right. Right. So right now you do. I would say for a lot of the search engines have that limitation, or it's more of an additive-only type mapping where you can add new behaviors, but you can't change the ones that you've already put in there. We take a similar approach. There's a couple of slight differences I'll call out. One is if you have a field where the type may vary. Let's say in some of your documents that field is a string, and in some of them it's a number. A lot of the Elasticsearch that I've worked the most with takes more of an approach of, well, which one is it? Do you want me to handle it like a string or a number? And you're kind of forced to decide. We've taken a slightly different approach where we can actually index both either way. I see someone disagreeing with me, so certainly let me know afterwards if you disagree with that. But we're taking a slightly different approach than Elasticsearch does. But I would say it's still an ongoing question in terms of how we're really going to support the mapping changes over time. It's a pretty simple approach right now of reindex with the new mappings. Any other questions? Okay, thank you all for your time.